Question 1. With the advent of high-efficiency energy management systems in commercial HVACR facilities, a technician is tasked with integrating a AE manage energy usage based on occupancy and weather patterns. The PLC must control multiple VFR-driven AHES lighting relays and HVAC compressors. The facility wants to reduce peak energy consumption during utility demand hours while maintaining comfort levels. Which programming feature is most critical? Implement an adaptive control strategy that adjusts dynamically based on input variables like outside temperature, occupancy, and utility rates. A. Ladder logic for direct relay control. B. Retentive counters to count cycle times. C. PID control loops with feedback from sensors. D. One-shot rising pulse for button-triggered override. Answer. Correct answer. C. Explanation. PID control loops are essential for adaptive responses in real-time HVACR applications. They allow proportional integral derivative tuning based on sensor feedback like temperature, or humidity. Unlike simple relay or pulse logic, PID adapts continuously. And CSRE standard 135 BACnet supports PID for dynamic control. Ladder logic and one-shot serve specific discrete tasks but lack continuous control. Retentive counters track events but cannot regulate variable loads. Question 2. In the context of a controlled chiller plant, Mr. Ramirez, a senior technician, observes that the system randomly trips during startup, especially when two chillers engage simultaneously. He suspects an analog input fluctuation. The PLC uses a 420 temperature sensor for chilled water input. What is the most appropriate first step for Mr. Ramirez to troubleshoot the issue? A. Replace the analog temperature sensor. B. Modify the PLC scan time for better synchronization. C. Use multimeter to verify signal current and sensor voltage. D. Disable one chiller in the ladder logic to isolate the problem. Answer. Correct answer. C. Explanation. Using a multimeter to measure the live 420 loop current and sensor voltage confirms whether the analog signal is stable or dropping. According to NFPA 70 NEC and ISA instrumentation standards, analog signals must be verified before making logic or programming changes. Replacing the sensor or modifying the ladder logic without confirming signal integrity can introduce unnecessary. Question 3. Among the various programming languages for PLCs, selecting the appropriate language can impact the maintainability and clarity of the system in an HVACR facility. An engineer must implement a complex sequence involving multiple AHES, chillers, interlocks, and time-based events. Which programming language offers the best readability for HVAC technicians while still supporting sophisticated control logic? A. Structured text. B. Ladder logic. C. Function block diagram. D. Instruction list. Answer. Correct answer. B. Explanation. Ladder logic is most readable for HVAC technicians who are often familiar with relay-based schematics. IEC 61131. 3 standards endorse ladder logic for discrete control and visualization. While structured text supports complex logic, it's less accessible to non-programmers. Function block is useful for analog operations but less intuitive for sequences. Instruction list is deprecated due to its low-level syntax. Question 4. To better understand system behavior is Jefferson programs. A for a dual compressor system that switches compressors based on load. After deployment, she finds that both compressors occasionally start at once, overloading the breaker. The logic uses 2 normally open, no start coils with interlocking contacts. What most likely caused this issue? A. Delay timer improperly set to 0. B. Interlocks configured as outputs instead of inputs. C. Contacts used in series instead of parallel. D. Scan time too fast to detect race condition. Answer. Correct answer. Explanation. Improper timer delay causes both outputs to energize before the logic executes the interlock. NFPA 79 and IEC 61131 3 recommend using on-delay timers to prevent simultaneous startups. Without a sufficient delay between commands, interlocks may not register before outputs trigger. Misconfigured timers are a common cause of startup overlap in compressor staging. Question 5. Considering the evidence, a technician is reviewing a ladder logic program controlling an OHU. The system includes A humidity sensor outputting 010V converted by an analog input module. However, the humidity readings are fluctuating drastically even though conditions are stable. What is the most likely cause? A. Improper analog scaling in the program. B. Loose terminal connections at the relay outputs. C. Incorrect PID tuning values. D. Short circuit on the 24th digital output module. Answer. Correct answer. Explanation. Fluctuations in sensor readings often trace back to incorrect analog scaling. The raw voltage must be converted using scaling equations or blocks to represent real-world humidity. If 010V isn't mapped correctly to, say, 0.100% RH, values will jump. ISA RP.4 and OEM sensor manuals guide scaling practices. Loose relay connections affect outputs, not inputs. PID tuning errors wouldn't explain unstable inputs. Question 6. In response to growing demand for energy efficiency, a facility integrates an AE system to monitor compressor runtime, chiller temperature differentials, and VFD fan speeds. Istahan is asked to create a routine to flag abnormal energy use. Which PLC instruction set is most suitable to compare current readings against historical baseline data? A. Move and JMP instructions. B. On delay timers and RET instructions. C. Math instructions with data registers. D. Output coils with normally open contacts. Answer. Correct answer. C. Explanation. Math instructions. E. G. Add sub VG combined with data registers or internal memory like D, N, or F files are best suited for trend analysis and threshold comparison. This allows calculating deltas and averages for monitoring. A move and JMP control flow but not data logic. Timers manage time-based operations, not comparisons. Coils control outputs, not perform analytics. Question 7. Based on the information, Istanuan is programming an A for a high-capacity AHU with multiple dampers and heating stages. The control logic includes sequencing based on occupancy sensors, outdoor air temperature, and return air co-levels. During testing, the dampers behave erratically and do not fully open or close. What should Istanuan verify first? A. That the dampers are not physically jammed. B. The analog output scaling and signal range. C. Whether the digital outputs are pulsing incorrectly. D. The retentive timers are not overwriting commands. Answer. Correct answer. B. Explanation. Dampers often use analog actuators 010V or 4 if output scaling is incorrect. G and 0100 mapped to 05 instead of 010. The actuator won't reach its full range, causing erratic behavior. Analog scaling should match manufacturer specs. According to ISA and manufacturer datasheets, accurate scaling ensures full actuator motion. Physical jamming is less likely if the issue is consistent and logic-based. Question 8. When evaluating the merits of different EO configurations for a large rooftop HVAC system, an engineer decides to use analog input modules with thermistors and pressure transducers and discrete outputs for valve solenoids. What is a valid justification for this design? A. Analog inputs save energy over digital inputs. B. Discrete outputs offer variable voltage control. C. Analog inputs are essential for continuous feedback. D. Discrete outputs can process sensor feedback directly. Answer. Correct answer. C. Explanation. Analog inputs allow continuous measurement of variables like temperature and pressure. This is crucial in HVACR where fine control and feedback are necessary. Discrete outputs are used for binary control on-off of actuators. NEC Article 725 and manufacturers classify analog and digital signals distinctly. Discrete outputs do not handle variable data or sensor feedback. Question 9. As demonstrated by a recent fault event in an AEV chilled water loop, O'Neill noticed that the system entered a lockout state after a brief power interruption. The PLC had volatile memory to store operating parameters, which upgrade would most likely prevent data loss and restore normal operation without manual resets. A. Increase the watchdog timer duration. B. Add an uninterruptible power supply ups. C. Replace EO modules with newer models. D. Implement analog scaling with floating point logic. Answer. Correct answer. B. Explanation. ALPS provides short-term backup power to allow the PLC to complete cycles or write to non-volatile memory. According to NFPA 7-tie and OEM design guidelines, critical control systems should have backup power to avoid unsafe states. Watchdog timers prevent logic hangs, not memory loss. Scaling logic doesn't retain data. EO upgrades don't address memory persistence. Question 10. In the absence of sufficient documentation, Mr. Ellis attempts to modify a ladder logic program involving multiple nested timers, interlocks, and jump instructions. After uploading his edits, several outputs no longer energize. Which best practice did Mr. Ellis most likely violate? A. He failed to simulate the program before uploading. B. He used floating point data for discrete outputs. C. He changed the scan cycle to priority mode. D. He replaced all retentive timers with non-retentive ones. Answer. Correct answer. Explanation. Failing to simulate or emulate changes before live upload is a common mistake that leads to system faults. Simulation helps identify logic breaks, latch errors, and sequencing issues. NFPA 7-tip and like 61131 recommend offline testing and full documentation before deployment. Timer or data type issues might also contribute, but the fundamental error is deploying and test logic. Question 11. The most significant aspect of ensuring a reliable PLC-based HVACR control system is protecting it from unpredictable voltage fluctuations and electromagnetic interference. Mr. Tobias is installing a 8-year A&L to control a condenser fan motor. He uses shielded analog cables but observes fluctuating temperature signals on the HMI during VFD operation. What is the best solution to resolve this issue? A. Replace the PLC with a model that has faster scan times. B. Route analog cables in separate conduits from power wiring. C. Add MOV surge suppressors on the analog input terminals. D. Change the analog sensor from 010V to 420M. Answer. Correct answer. B. Explanation. Routing analog signal cables separately from high voltage power wiring reduces ME per NEC Article 300 and IC 6100004M compliance. Analog voltage signals are more prone to interference, especially in VFDS. Shielding helps, but cable segregation is more effective. MOVs are used for surge protection, not ME mitigation. Faster scan times won't address physical interference. Question 12. Through careful analysis of a failed boiler sequencing PLC program, is Riley determined that the second stage ignition does not trigger even when demand is high. The logic uses interlocks and a latch coil. She suspects the issue lies in the interstage sequencing. Which of the following should she investigate first? A. Whether the EO modules are defective. B. Whether the latch coil is being reset by a low priority run. C. Whether the scan time is exceeding 500 is a D. Whether the ignition transformer has mechanical. Answer. Correct answer. B. Explanation. Latch coils can be unintentionally reset if a low priority run with a reset command executes later in the skin. PLCS process top-down and misplaced resets override logic. NFPA 79 and ISA 5.1 recommend careful use of latches and reset instructions. EO faults and hardware wear should be checked after logic level issues are eliminated. Scan time exceeding 500 ms is rare and not the likely issue here. Question 13. During the process of upgrading an HVACR control system, a contractor must integrate a new HMI with the existing PLC that monitors AHU damper positions and compressor cycles. Which of the following is most critical for ensuring compatibility and real-time communication between the HMI and PLC? A. Availability of Modbus or Ethernet protocol support. B. Matching EO module types between HMI and PLC. C. Shared power supply source between both systems. D. Both devices using ladder logic programming. Answer. Correct answer. Explanation. Communication protocols like Modbus, CPIP, BACNetIP, or Ethernet are essential for interoperability between HMI and PLC. According to ISA 95 and the ASHRAE BACnet standards, protocol mismatches, a leading cause of integration failure. HMIS do not require direct EO connections or programming language compatibility. Power sharing is irrelevant if devices have isolated supplies. Question 14. From a practical standpoint, Mr. Everett is reviewing a program for an energy optimization sequence where VFD controlled supply fans in an OHU respond to duct static pressure. However, the fans ramp erratically and sometimes oscillate. What is the most likely cause? A. Improper hysteresis setting in the output logic. B. Poor PID tuning parameters for the control loop. C. Faulty discrete sensor wiring. D. Coil suppression devices installed backward. Answer. Correct answer. B. Explanation. Erratic ramping and oscillation in VFD fan control typically result from poorly tuned PID parameters. Gain integral derivative. HVACR PID loops need to be tuned based on response characteristics of the mechanical system per ISA TR.2. Hysteresis effect switching, not analog ramping. Discrete sensors don't apply here, and backward coil suppressors cause hardware faults, not loop instability. Question 15. Given the circumstances where Mr. Leblanc needs to scale a 4-2 euro pressure signal for display on an HMI ranging from 0 to 300 psi, what is the correct linear formula you should use inside the PLC logic to convert the raw input to engineering units? A. Engineering value equals raw 4x75b. Engineering value equals raw 416x 300c. Engineering value equals raw x 320d. Engineering value equals raw 4x 316. Answer. Correct answer. D. Explanation. The correct linear formula to scale a 4-2 euro signal to engineering units is engineering value equals raw 4x span 16 where span equals 300 psi. This formula follows ISA 51.1 standards for analog scaling. Option D reflects this rule. Option C is used for 0-2 euro inputs, which is incorrect in this 4-2 euro case. Option omits the denominator. Option B misorders the operations, leading to misrepresentation of pressure. Question 16. Focusing specifically on a sequencing routine for a multi-stage rooftop HVAC unit, Mr. Waters notices that the third compressor stage never turns on, even though the first and second are active and demand remains high. His ladder logic includes comparison blocks and a rising edge trigger. What is most likely causing the issue? A. The third compressor's contactor is faulty. B. The comparison block threshold is set too high. C. The rising edge trigger resets every scan cycle. D. The EO configuration is missing analog scaling. Answer. Correct answer. B. Explanation. If the comparison threshold that triggers stage 3 is too high, the condition to energize it is never met, even with high demand. This is logic level configuration issue. PLC programs using equals or blocks must reflect accurate set points per ASHRAE controlled sequences. Faulty contactor would prevent physical startup but not logic failure. Rising edge triggers resetting every cycle is normal unless misused. Question 17. By evaluating the impact of loop response time in a chilled water system, Mr. Gomez finds that the PID loop controlling valve position takes too long to react to load changes, resulting in occupant discomfort. What adjustments should you make to improve system responsiveness? A. Decrease the integral time constant. B. Increase the derivative gain. C. Use on delay timers on the output. D. Add deadband logic to the analog input. Answer. Correct answer. Explanation. Reducing the integral time allows the PID to eliminate error more quickly, making the system more responsive. ISA PID tuning methods, Ziegler-Nichols or Cohen-Kuhn, support this adjustment for HVAC loops. Increasing derivative gain may cause overshoot or instability. On delay, timers add lag. Deadband logic reduces sensitivity and may worsen delay. Question 18. Examining the consequences of incorrect PLC memory addressing, Mr. Donovan uploaded a program for a boiler feed water control system but found that activating one pump also triggered unrelated outputs like alarms and solenoids. What is the most likely cause? A. Power supply not grounded properly. B. PLC scan cycle corrupted during upload. C. Memory addressing overlaps in the data table. D. Output card firmware is outdated. Answer. Correct answer. C. Explanation. Overlapping memory addresses. E. G. Using the same bit or word in multiple runs causes unpredictable behavior in outputs. This is a common ladder logic mistake and is preventable through modular design and address tracking. Like 61131 recommends clear EOM internal tag separation. Firmware and grounding issues may cause general faults but not cross-triggered outputs. Question 19. Contrary to popular belief, retentive timers in program for HVACR systems are not always ideal. In a ventilation purge sequence, Alvarez used a retentive timer RTO to delay exhaust fan shutdown after occupancy ends. However, the fan now runs for hours after a brief power loss. What should she do instead? A. Use the turn non-delay timer with reset logic tied to occupancy. B. A separate battery backup for the exhaust fan. C. Use an HMI button to manually reset the timer. D. Increase the time preset on the RTO. Answer. Correct answer. Explanation. RTOs retain elapsed time after power loss, which can mislead the system into continuing operation when power returns. A ton timer with explicit reset logic based on occupancy avoids this issue. Like 61131 logic design recommends using non-retentive timers for timeouts that should not persist through power cycles. Manual reset buttons and battery backups do not solve logic persistence issues. Question 20. While examining the building automation network of a chilled water plant, Istasing needs to ensure that his PLC-based compressor controller integrates properly with the BACnet-compatible BAS system. Which of the following is most essential to achieve this? A. All devices must operate under the same time zone. B. The PLC must support BACnet-IP or BACnet-METP protocols. C. The BAS must be written in structured text language. D. The PLC must have more than 256 EO points. Answer. Correct answer. B. Explanation. To integrate with a BACnet-compatible BAS, the PLC must support BACnet protocols, either API or METP. HRI 135 requires proper object mapping and protocol support for communication. Time zones and EO count are irrelevant to network compatibility. Programming language does not affect BACnet communication capabilities. Question 21. Across different scenarios, Mr. Wallace is designing a controlled ventilation system that adjusts airflow based on both indoor air quality and occupancy sensors. During testing, the system fails to reduce fan speed when co-levels fall below the threshold despite the analog input showing correct values. The output is controlled via VFD connected to an analog output module, which should be the first item he reviews in his program. A. PID loop error output saturation. B. Scaling of the analog output signal. C. Co-sensor calibration settings. D. VFD MOA frequency limit settings. Answer. Correct answer. B. Explanation. Improper analog output scaling can result in incorrect voltage or current signals sent to the VFD, preventing proper fan speed modulation. ISA RP.4 and PLC manufacturer guidelines stress correct analog scaling between engineering units and output signal range G0 1 EROV or 4 2 Zeroma if the co-value is right, but the VFD in responding output signal conversion is likely incorrect. Question 22. In what ways can PLCS be applied in HVACR-specific safety interlock design for boiler operations? The technician is tasked with ensuring that a combustion air fan is running before the burner can be energized. Which of the following logic structures best satisfies this safety requirement? A. Set reset latching circuit with delay. B. Time-based cyclic output without input condition. C. Interlock condition using normally open contact from fan status. D. Toggle bit from HMI reserve input. Answer. Correct answer. C. Explanation. A safety interlock using a normally open contact from the fan status input ensures the burner can only energize if the fan is verified to be running. NFPA 85 and ASM CS01 require airflow verification prior to burner ignition. Set reset circuits may cause unsafe conditions after power failure. HMI toggles are user-dependent and unreliable for safety. Question 23. By comparing different logic implementations for a multi-stage HVACR compressor bank is to take that observes that stage 2 engages even when stage 1 is not running. The ladder logic uses comparator blocks and one-shot triggers for each stage. What is the most probable programming oversight? A. Improper use of rising edge trigger in stage 2 logic. B. Stage 1 interlock is wired as an OR condition instead of an. C. Delays between stages are configured in reverse order. D. Timer presets exceed the PLC watchdog timeout. Answer. Correct answer. B. Explanation. If stage 1 interlock is programmed as an OR condition instead of an and with stage 2, then stage 2 can falsely activate independently. Interstage dependency is crucial in compressor control sequences. Per ASHRAE control standards and NFPA 70, logical dependency must be enforced through proper conditions in rungs. Question 24. During the process of testing a newly installed chiller control panel, Mr. Alvarez uses A to monitor compressor current via analog inputs. The readings are erratic and spike when the compressor starts. He is using a 0-1 year of output CT current transducer. What can best help stabilize the readings in the logic? A. Switch to 24K digital CT for threshold detection. B. Apply moving average filter or software smoothing function. C. Increase analog input module's resolution from 10-bit to 12-bit. D. Reduce scan time to under 1 ms for faster sampling. Answer. Correct answer. B. Explanation. Applying a moving average filter helps smooth out transient spikes and erratic data common with analog CTS. ISA and PLC vendors recommend digital filtering or software averaging for HVACR loads with inrush currents. Increasing resolution or reducing scan time can help but do not address the core noise issue. Question 25. The foundation of precise analog input processing in HVAC PLC applications lies in accurate interpretation of raw data. Is Donovan connects a tank thermistor to an analog input module via a signal conditioner. However, the readings on the ETMI show erratic temperature swings. What is the most probable cause? A. The signal conditioner is not converting resistance to voltage correctly. B. The PLC logic is using incorrect pit tuning for the thermistor. C. A mismatched NTC resistance curve was selected in the logic. D. The analog input is wired to a digital-only terminal. Answer. Correct answer. Explanation. Thermistors are resistive sensors and require signal conditioners to convert resistance into voltage or current. If the conditioner fails or is incompatible, the analog input receives incorrect data. ISA and HVACR control system manuals emphasize proper sensor signal conditioning matching. Using wrong curves or digital terminals may cause issues but won't explain the erratic voltage levels. Question 26. From multiple perspectives, integrating a control air handling unit with VFDS and dampers requires managing startup sequences to avoid mechanical damage. Vista Singh notices that the supply fan starts abruptly, causing pressure shocks. The PLC uses a digital output to enable the VFD. What adjustments should be made? A. Replace the fan with a soft start motor. B. Use an analog output to ramp the VFD reference signal. C. Decrease scan time for better response. D. Move the enable output to the main safety circuit. Answer. Correct answer. B. Explanation. Using an analog output to gradually ramp up the reference speed signal to the VFD prevents abrupt starts and pressure transients. Per IC 6180051 and VFD integration standards, analog control enables smoother acceleration profiles. Enabling via digital output without analog control causes instant full speed operation. Question 27. The underlying principle of a properly functioning state machine in an HVAC PLC program involves clear transitions and persistent memory. Mr. Wheeler develops a state-based control routine for a heat pump using integers to represent modes e.g. 0 equals off, 1 equals heat, 2 equals cool. After a start, the system always reverts to off regardless of the previous mode. What's the most effective way to preserve the system state? A. Use non-retentive memory location for state storage. B. Implement retentive integer tags stored in battery-backed memory. C. Use analog scaling logic to reinitialize state. D. Use timer coil to latch previous outputs. Answer. Correct answer. B. Explanation. Retentive tags stored in battery-backed memory allow the PLC to recover system states after a power cycle. IC 61131 programming best practices specify this for state machines. Non-retentive memory Resets on power loss. Analog scaling and timers are unrelated to state retention. Question 20. Taking into account digital logic structure in EPESIS, a technician notices that activating one output disables a related one due to overlapping logic branches. The output coils are placed at different parts of the program but are controlled by different contacts. What best explains this malfunction? A. Multiple coils assigned to the same output address. B. Incorrect scan order of the subroutines. C. Missing end statement in structured text logic. D. Watchdog timer is resetting the logic. Answer. Correct answer. Explanation. Having multiple output coils assigned to the same address causes conflicts, especially if set under different conditions. Only the last one executed during the scan determines the final output state. This violates IEC 61131 design rules and can lead to unpredictable outcomes. Scan order matters, but overlapping coils are a direct logic flaw. Question 29. When presented with a scenario where Mr. Harris needs to control 4 stages of compressor load in response to temperature demand, he uses cascading timers and comparator blocks in ladder logic. However, after a few cycles, stages stay latched and fail to reset. What is the most likely issue? A. Lack of interstage manual override. B. Missing reset condition for latched outputs. C. Incorrect comparator thresholds for cooldown. D. Faulty analog module causing frozen inputs. Answer. Correct answer. B. Explanation. Latches must always have defined reset conditions to ensure proper sequencing and to prevent outputs from remaining stuck. According to best practices in HVACR staging logic, improper or missing resets lead to load mismanagement. Comparator issues may delay reset but not completely disable it. Frozen analog inputs typically result in fixed readings, not latched outputs. Question 30. Under the assumption that Lin is programming a sequencing routine for 3 chilled water pumps where each pump must operate in rotation for equal runtime, what is the best method to implement this logic? A. Use the PID loop to balance operating time. B. Hardcode daily alternation of each pump. C. Use runtime accumulators and comparison logic. D. Switch pumps manually using HMI interface. Answer. Correct answer. C. Explanation. Using runtime accumulators allows comparison of accumulated hours or cycles to determine which pump has run the least. IEC 61131 programming and ISA control system standards recommend such logic for duty rotation to ensure equal wear and extended equipment life. Manual switching or fixed schedules are less adaptive and introduce human error or imbalance.